Hello, everybody. It's Mrs. Pound, and we are currently studying Chapter 3.2 on chemical reactions from purposeful designs, physical science. Today, we're going to talk about Section 3.2.2 on reaction rate. Our objectives for today are to analyze factors that affect reaction rates and to compare catalysts and inhibitors. First, we have to know what a reaction rate is. This is a measure of the change in concentration of reactants over a period of time. If the change in concentration, which concentration has to do with how packed basically the molecules are in there, how many of them are there, and how packed they are. So something that is highly concentrated is going to generally have a darker color, and something that's less concentrated will lose its color over time as the reaction takes place if it's a colored substance. So you can think of it that way. Reactions can happen very quickly. They would have a high reaction rate, or very slowly, a slow reaction rate. So the change in the reactants would be slower or faster. Two conditions that must exist for molecules to react with one another are the molecules must collide with enough force. And these goats in this picture, they are fighting. They have collided together. And you can imagine if they collided with enough force, maybe their horns would lock and they wouldn't be able to pull apart. Also, these collisions must be in the proper orientation to react with another. So here we have a baseball and a mitt. And if you were catching a baseball, if you didn't have the mitt or the glove oriented just right, you would miss and not make that connection. So 5 factors that affect reaction rates are: number 1, temperature. Increasing the temperature generally increases the reaction rate. The reason for this is as we increase temperature, the molecules are moving faster, so they're more likely to collide and hit with more force in the proper orientation because they're really tumbling around a lot as well. So if we lower the temperature, we would decrease the reaction rate because they're slower. Also, surface area. A reactant crushed or ground into smaller pieces has more surface area than one large piece. So with the surface area, you're increasing that. You're also increasing the collisions. And I know that making coffee is not a chemical reaction, but we grind the coffee so that it takes a shorter amount of time for us to get a lot of flavor into our coffee than if we had the whole beans. If we had the whole beans, it would take a very long time because there are less collisions with the water molecules, even though this is more of a physical change. There are less collisions with the water molecules because it's a larger surface area. You increase that surface area, you increase the number of collisions. Also, concentration. Reaction rate increases when the concentration of the reactants is increased in the rate determining or slow step. Many times, chemical reactions have more than one step. And the slowest step is the rate determining step. So if you were to change the concentration at any of the other steps, it wouldn't affect it. You have to put it at the slowest step, increase that concentration. So for example, if you are making sandwiches and you have 2 people putting mayonnaise on the sandwich, 2 people putting meat on the sandwich, and only 1 person wrapping, the rate determining step would be the person wrapping the sandwiches because that will take a longer time because you only have 1 person. So if you wanted to speed up that process, you would have more people wrapping the sandwiches. And in the picture in the background, the color that is darker is more concentrated. So there are more molecules there to more reactant to react. And so because there's more reactant, there's more collisions. With this concentration, we can also use a formula. So the rate of reaction equals the change in concentration over the change in time. So a problem we might see with this is calculate the reaction rate of an experiment that contains 20 reactant units after 30 seconds have elapsed. The initial concentration is 50 units. So the first thing we should do is rewrite that equation so that I know what equation you are using for the problem. So go ahead and write that down. Rate of reaction equals change in concentration over change in time. The next step would be to plug in the numbers. We would say that we started with 50 units, we ended with 20 units, so 50 minus 20 over 30 seconds, which is the time. So the 50 and the 20 are the change in concentration. The 30 seconds is the change in time. We would subtract 50 minus 20 and get 30 units over 30 seconds. And if we do the division, it's 1 unit per second. So that is the rate of reaction. Another factor are catalysts. A catalyst is a substance that increases the reaction rate without being permanently changed. So that's kind of like using tools to speed up the reaction. If we are trying to put a nut on a bolt, we might use a wrench because it makes it easier to do. We'll be faster at doing that job than if we just try to put it on with our fingers. So that would be kind of similar to a catalyst. And it also has to be the right shape a lot of times. Okay. And so the wrench has to be the right shape to fit the nut that you're using. So a catalyst also has to be the right shape to fit the reactant that you're using. And one thing to note is that biological catalysts are called enzymes, and like the wrench, they are very shape specific. I have a glass of milk in the background because some people, when they drink milk, it contains a sugar called lactose, but they cannot digest that because they lack the enzyme lactase. So they must actually they can ingest lactase as a pill to help them digest the milk. And enzymes are important in the body because a lot of the reactions that take place would have to take place at higher temperature. This lowers the temperature at which those reactions take place. Otherwise, we wouldn't be able to perform those reactions in a timely manner. And then there are inhibitors. An inhibitor is a substance used to slow down or stop a chemical reaction. An example of an inhibitor are the preservatives that we put on lunch meat. It slows down the activity of bacteria in breaking down that lunch meat. What happens is oftentimes what they do is an inhibitor will, say, cover up the surface of a reactant so that it cannot react with the other reactants properly in the proper orientation. And so they cannot line up properly. So it slows everything down a little bit. And just a special note, like catalysts, inhibitors are not permanently changed after a reaction and can be recovered and reused. So this is useful in biological systems. After the enzyme works on a reactant, it will disengage and work on another reactant. So our objectives were to analyze factors that affect reaction rates and compare catalysts and inhibitors. Don't forget to keep watching the video to answer the questions at the end. And also don't forget your 5 questions in the margin of your notes for this video. And I'll be back with another video for this chapter.